let me pick up on, and we can work through this fairly quickly. So those of you with good memories will recall we launched this project almost 3 years ago now. It went through a significant transformation midstream as we were talking to you guys and your counterparts about how could you actually use a best practices guide around to the chiller plant. The document is now up on the Greening Healthcare website. You can see the address there. You can access the whole thing, and we encourage you to do so. But the pieces we wanted to flag today, one is to let you know it's there, and it's a good idea to take a look at it, either when you have a new capital project, like a chiller addition or replacement, or at the start of each cooling season when you're figuring out how to best run the plant going forward. But this is what the cover of the document looks like. Again, thanks to Clenzoid and EMEC, as well as the ISO and Toronto Hydro for the funding support they provided to make this possible. That's where you find the document on the Greening Healthcare website under research and case studies. And it is now constructed around 2 checklists, one of which is design, retrofit, and expansions. And it is this simple. There aren't that many things that you would check off saying, did this, that doesn't apply, but this thing we need to look into. And then the guide, you'll find a section in the guide on each one of these items that you can go and read if you want more information. The 2 highlighted here that I wanted to flag for you today are the chiller selection. So we're talking to one of the member hospitals right now that needs to replace a chiller. They just lost 2 chillers, actually. They need to replace them, and it's time to look at the heat recovery chiller, and that's the option at the bottom there. That do you want to replace it with a conventional chiller or a heat recovery chiller? In fact, 2 of the member hospitals we're working with now to look to answer that question. So these are your capital project measures on the checklist, and here are your operations and control measures on your checklist. So the chiller sequencing, supply water temperature, these things are on Harry's long list of operational improvements that we looked at earlier. But there's a fairly comprehensive list there that had a fair amount of thought that went into it. And again, there's a section in the guide that provides more detail on each of these. Go read it, have fun with it, because it is I think it's a very user-friendly and practical document now. But these controls issues take us to, and I'll ask Amandeep to share a few thoughts. One of the disappointments we had was that very few hospitals have trend logs set up or archived on key things like which chillers are running, which cooling towers are running, what's the chilled water supply temperature. So Rob Simpson, who was on just a second ago at Ontario Shores, was kind enough to share. And if you remember, he's already at his cooling electric target. So he's a very efficient plant. But the trend logs here, this information is showing there's still more to be done. So Amandeep, can you just kind of briefly walk us through what is this telling us in terms of the outdoor air temperature and how the plant is running on the lower charts there?
Yeah, thanks, Ian. So basically what you're looking at is 2 graphs. The top graph is we picked up the Toronto weather temperature, which is very similar to Ontario Shores site weather temperature. So what you're looking at is the top is the weather. As you look at it, this is for the month of June. The weather goes basically up and down. It ranges from 10 degrees C all the way to 30 degrees C. And at the bottom graph, you see two lines, blue and red. Red is the supply water temperature, and blue is the return water temperature from the chiller plant. So what you could see in this graph is that even with the temperature dropping in the middle of June, almost close to 15 or even close to 12 degrees C, there's no, currently there's no reset on the chilled water supply water temperature. So which is what we do.
No automatic reset. Rob's
no automatic, yes.
Manually. Okay.
Yes, they do it manually. So there's currently no automatic reset, and which is what a high performing chiller plants looks like, as eventually you want to move into that transition is where you have automatic resets on the chilled water supply temperature, and could be temperature as could be one of the key, or it could be your key on the load as well. So whatever system, whatever the programming work for you, but at least there has to be some sort of an automatic reset so that you can maximize the energy efficiency on your plant.
And then looking at the way the plant actually operates, it's the same outdoor temperature profile, right? But this is, what do we have here? The cooling towers?
So yeah, it is the same. This is, I mean, this is another reason why we want to see the trend logs archived at a 15-minute interval for a long period. So you can look at historical data and see how's your chiller plant is performing. So basically in this graph, you're seeing is the weather temperature. And at the bottom graphs, you're seeing the chiller enable or disable point. So when you look at chiller 2 and 3, there are 2 chillers currently running. You look at the red circles, those are the times when both the chillers were running. And if you look at the third circle from the left, which is the red circle, at this point of time when the outside weather is around 22, 23 degrees C, you don't need the second chiller to come on. And actually, in fact, all of the times when you have the 2 chillers come on at this time, you did not need those 2 chillers come on, because when you look at the blue circle, that's the blue circle when it was 30 degrees outside and 1 chiller was able to maintain the set point in the building. But all the other times, even the outside air temperature was lower, still the 2 chillers were coming on. So this set of, like, you could only figure this out if you have a good set of trend logs to optimize the chiller system. And I mean, in this case, all Rob needs to do is basically review their programming language to make sure that the second chiller doesn't come on when it's not needed.
The other thing you're showing me is cooling tower 3, the green one at the bottom there, regularly goes up to 100% fan speed, and that's the most inefficient that a variable frequency drive can be. So better control of the cooling towers would also help a bit with it.
Definitely, definitely. And another thing you notice is, especially the third circle, is you can see the chiller came on because there was a drop in the chiller or cooling tower speed, or there was a switchover between the 2 cooling towers. So that kind of resulted maybe a supply water increase in the chiller and brought on the chiller for only 20 minutes or 30 minutes, and then it went off. So you don't need that kind of 2 chillers running at that time, and you can only get away with 1 chiller.
Perfect. Thanks for this, because I think it makes the case very well, and everyone needs takeaways from these sessions. There need to be something that you do when you get back to back to your desk. And the first request that we make, because so many hospitals don't have them, is just chat with your building automation supplier first for what will it cost to set up and archive the trend logs. 24 months is good, so you can look back to last season and the season before. And automating chilled water supply temperature reset is remarkably effective in achieving electricity reductions. And if you're not sure about any of that, again, we got Amandeep's contact information at the end of this presentation today. Call him if you're not sure about that. But we're hoping that every one of the hospitals, on every Greening Healthcare member hospital, will take that step 1 there. Let's get trend logs set up and archived so we can be more useful together in identifying all the ways that really big electricity savings can be made. So chiller plants, and obviously when you have a quiet moment, go take a look at the best practices guide, have a look at the checklists, share them with your staff, and kind of work your way through a seasonal basis to review the chiller plant and how it's running.